Hi everybody, welcome back. Today I want to go over homework number 6 in Principles of Microeconomics in Econ 1B. And this is the homework assignment that deals with firm costs and production. So we are switching gears and talking about firm behavior and firm decision making, which means we got really comfortable with these curves right here. And that's where we're going to focus our energy, is talking about explicit costs and implicit costs, accounting profit and economic profit, total cost, variable cost, fixed cost, short run, long run, average costs, so average total cost, average variable cost, and yes, average fixed cost a little bit. And then most importantly, marginal cost. And that's going to come from this idea of diminishing marginal returns. And so here on this graph, I've got the same kind of graph that you're going to see in problem 1. I've got a marginal cost curve that's going to have that fishhook shape. And we've got a quantity here, quantity 1. That's where marginal costs are minimized. And that's also going to be where we see that diminishing marginal product effect take place. Because remember, and we're seeing that here in the homework, in last week's material and next week's material, labor is going to cost the same at every level. When it becomes less productive, it's going to cost us more to produce the next quantity, the marginal quantity. And so as the marginal product diminishes, the marginal cost is going to be rising to meet it. And that's something I'll try to show you in this answer key just to give you a better sense of it. So this is very, very similar to what that first problem in the homework is, problem 1, where we're looking at finding the quantity at which we see the diminishing marginal returns or diminishing marginal product of labor set in. We can see where average variable cost is minimized. It's going to be at the point where it's equal to marginal cost. Where average total cost is minimized, again, where it's equal to average, or where it's equal to marginal cost, and just some details about the shapes of these curves. So I'm going to go ahead and throw this up on the, throw the assignment up behind me so you can look at the assignment as we go through it. And we'll go through these first few problems and talk about what they mean and how to solve them and the why of it all. Okay? Okay, so here's the exact same graph, right? It's in boring black and white, but we've got our marginal cost curve in a fishhook shape, our average variable cost in a smiley face shape, and our average total cost, which is going to be far away from average variable cost at first, but they get closer and closer together as we get closer. And so the first thing we want to do is answer the question, at which quantity is the total cost of production minimized? And we minimize our total cost when average total cost is at a minimum. That's going to be at the quantity of Q4. So at Q4, average total cost is at a minimum. We want to remember these average cost curves are displaying the average at every stage of production. So as we move down here, we're seeing average costs fall because the marginal cost is below average. And when you're adding a small number to an average, it's going to keep pulling that average down. But as they get closer together, we get to the point where they're actually equal. And then marginal cost is higher than average cost. And that means that it's going to be pulling that average up, right? We did this example in class. If you have an 80 in the class and your next assignment has a grade of 90, that's going to pull your average grade up. So when the marginal value is higher than the average, it's going to pull that average up. So we're going to expect average total cost to be minimized here when it's equal to the marginal cost at a quantity of 4. So let's go ahead and write that. Which quantity represents the point after which the firms experience diminishing marginal returns? Again, we want to always remember that marginal cost is the other side of diminishing marginal product. And I'll try to do an example of this for you all at the end. But the general idea here is that if we look at the marginal product of our workers, we're going to see it have this relationship of rising and then falling. And that's going to be directly connected to the marginal costs that we're going to see in our marketplace, in our firm, because our firms are going to face falling and then rising marginal costs, and the peak marginal product is going to be equivalent to the lowest marginal cost, because as costs, as worker productivity rises, the cost of producing output falls. So if I'm hiring more and more workers to make books in my factory, if each worker is more and more productive, it's going to cost me less and less to produce more books. But as each worker gets less productive in terms of producing books, it's going to get more expensive to hire enough workers to get another book made, basically. I'll try to give you all another example of that. So we're going to see the quantity which represents the point after which the firm is experiencing diminishing marginal returns is going to be Q1. The gap between average total cost and average variable cost represents the average fixed cost, and they're not up here. Oh, I got rid of my curves. They're not up there because really it's not the most important thing in the world. But if we go back and put our cost curves up, we want to remember, oops, there we go. There's marginal cost, and we've got average variable cost and average total cost. The gap in between average total cost and average variable cost is average fixed cost, because average total cost is average variable cost plus average fixed cost. So that means if I were to take the variable costs out of total cost, I would be left with the fixed cost. And we can think about it this way, that average fixed costs are going to always be falling. And so this graph plus this graph gives us this graph, is the idea. So the space in between average total cost and average variable cost represents our fixed costs. Okay? Hopefully that makes sense. If not, look at the numerical examples. I think that helps. Oops, and I want to make sure I'm differentiating between total fixed costs and average fixed cost. Cool? So far, so good. The firm depicted in the graph may have to pay higher rent. If they have to pay higher rent, which curve would we expect to shift, and will we expect it to go up or down? We want to remember that without this average fixed cost curve built in, the only place, well, first of all, we want to remember, first, I'm getting ahead of myself. We want to remember that paying rent is something that does not scale up or down, does not increase or decrease as we produce more or fewer units. It's not going to be something we can change today or tomorrow. It would take time. So it's going to be our fixed costs. And if our fixed costs increase, an increase in fixed cost is not going to show up here or here. It's going to show up in average total costs, and it's going to be a shift up. So however much rent goes up, that's going to shift that average total cost curve up. Because average total cost, again, contains the fixed costs right here. And so if this goes up, then this will go up. And so if we have to spend an extra $50 a month on rent, that's going to shift that total cost curve up. So if the landlord raises rents, we expect it to shift average total cost up by the average amount of rent. So far, so good. Hopefully that makes sense. Let me know if you have questions or if you want a specific example of that. The next question, we have a commercial fishing person who notices the relationship between hours spent fishing and the number of fish caught. The first thing we want to do is derive the marginal product. of each additional hour of fishing. And so this is a little bit different, right? We're not talking about adding workers. We're talking about one worker adding more hours. So what we want to see here is, excuse me, how each additional hour produces more fish on the margin. And again, really, we're just diving into this marginal relationship, this idea that we see these things change with each additional unit, right? So if we move from 0 hours of fishing and 0 fish to 1 hour of fishing and 10 fish, the marginal product of that first hour is going to be those first 10 fish that are produced. And then in the next hour, this person is going to find that they actually produce a total of 19 fish overall, which means that second hour had a marginal product of 9 fish. The next hour gets to a total of 25 fish, so that 3 hours of fishing produces a total of 25 fish. The third hour takes the fishing person from 19 to 25. That's a marginal product of 6 fish. Then the fourth hour is less productive. They just go from 25 to 27. So that's a marginal product. That extra hour produces an additional marginal amount of 2 more fish, right? 5, 6, 7. Yeah. And then finally, in the fifth hour, that's the least productive hour. This person fishing only produces 1 fish on the margin in that last hour. So that's our marginal product of fishing. And then what we call this effect over time, where as we add more hours, the quantity of fish decreases. That's just diminishing, marginal product, right? It's the marginal product of each hour of fishing producing less additional fish, fewer fish on the margin. Okay, this next problem was a little bit of a tougher cookie in some ways. Oh, that's way too big. But the idea here is that we have a person doing small level production, and I'm going to ask what fixed costs are, what variable costs are, what's accounting profit, what's economic profit, and then the last question is this business making money or not? And does it depend on how we measure that? So let's go through and we'll do what I like to do with any word problem, which is kind of diagram it out so that it makes at least some more clear sense. So you and your roommate start an Etsy shop crocheting crafts to make some extra money instead of working on campus for $12 an hour. So we want to remember right here that our opportunity cost of our labor is $12 an hour, because that's going to come into play later. And it's just this idea that, hey, I could be working and making $12 an hour at some job on campus. Now we want to go through and look at the different costs associated with this business. So we're going to say that it costs us, we sell 50 crafts over time. So I'll do it in this color. Let's do purple, that's fine. Q equals 50. And the price of each craft that I sell, our price is gonna be $45. And if you're already looking at the chapter on perfect competition and perfectly competitive markets, you might remember that price in a perfectly competitive market is equal to marginal revenue. So that's just a little Easter egg there. But that means that our total revenue is gonna be 50 crocheted crafts times $45 each, or a total revenue of $2,250. So far, so good. Now we want to look at the costs. In terms of costs, we have explicit costs, which is going to be anything we spend money on. So we spend $350 to Etsy to open, $325 to Etsy to open our business, right? So let's go ahead and mark that. That is definitely an explicit cost. So we'll highlight it. We spend $25 on crochet needles, definitely an explicit cost. We spend $20 on yarn per each craft, plus $5 on packaging to make it look pretty. And we also use our apartment to make the craft, and we use our time. Those are not explicit costs because we didn't pay for them. So our explicit costs are going to be our $25 Etsy shop, or our $325 Etsy shop, our $25 for the crochet needles or the crochet hooks, and then we're going to have $20 per craft for yarn and $5 per craft for packaging. Already we see a difference between these explicit costs. These two are the same no matter how much we produce. That means that those two are going to be our fixed costs. They're fixed because they don't change whether we produce 1 or 50 or 0. They stay the same. The $20 per craft and the $5 per craft for packaging and for the yarn used to make the craft, those are going to be our variable costs. They scale up and down as we produce more or less. So far, so good? So if I want to go through and find the total fixed costs, our fixed costs are going to be, $325 plus $25, or our fixed costs are $350. So far, so good? Our variable costs, on the other hand, are going to be based on these costs per unit. So remember, I said I made 50, so my variable costs are going to be $20 plus 5, or $25 times 50 crafts, which is going to give me a total variable cost of $1,250. Does that make sense? So now we've got our fixed costs here and our variable costs here. And that answers part A and part B, right? Our fixed costs are going to be, let's change colors here for fun. Oops, let's do that. A total of $350. And our variable costs are going to be a total of $1,250. Now we want to calculate our accounting profit. And we remember that accounting profit is going to be our revenue minus explicit costs. Anything we spent money on subtracted from the money we made. So we have our total revenue up here, $2,250 minus $1,250 and $350. So that's going to give me a total of $1,250 plus $350. Our explicit costs are $1,600. Does that make sense? Fixed plus variable, anything I spent money on. So my accounting profit is going to be $2,250 minus $1,600, or a total accounting profit of $650. So far, so good? Does that make sense? So we're calculating our profit based on the revenue we earned and our explicit costs. But we want to remember from learning about implicit costs that there's also an opportunity cost associated with this work. We used space in our apartment and we used our time. those things didn't cost us money, right? They were things we already had, but they still have value. My labor was worth, or this person's labor was worth $12 an hour, and they had an apartment which was worth $2,000 times 10% to use one small part of the office or one small part of the house. So if we want to calculate the implicit costs, we want to remember that implicit costs are also our opportunity costs. So those are going to be 10% of our apartment and 2 hours at $12 an hour for our labor. Again, we don't pay those costs, but instead of making crafts, I could have worked on campus and made $24. So every time I make a craft, I'm going to give up 2 times $12. So that's going to be 2 times $12 is 24 times the 50 crafts I made is $24 times 50 plus the $2,000 apartment times just the 10% of the apartment I'm using. So that's going to give me implicit costs of, let me use my cheat sheet here, $200 for the apartment and $1,200 in foregone wages. So my total implicit costs are actually $1,400. So if I want to come back up here and calculate my economic profit, it's going to be revenue of $2,250 minus explicit costs of $1,600 minus implicit costs of $1,400, giving me a total economic profit of negative $750. And the whole solution to this larger problem is in the question for part E. Your roommate thinks the business is making money and you should keep selling crafts, but you don't think it's worth the money you earn. So yeah, explicitly, you're making $650 by selling these crafts. But if you consider the value of all that space you took up in your apartment to do it and the value of your time, you're actually losing money. And you can think about it, even if we excluded the $200 for the apartment, you're still losing money. You could have made more money by just going to work on campus. So that's the idea there. So let me fill in the rest of these. The accounting profit is going to be revenue minus the fixed costs of $350 plus the variable costs of $1,250, or a total revenue of $650. But the economic profit is going to be the same revenue as before, but now we have to consider the implicit costs or the opportunity cost as well. So it's going to be minus those explicit costs here, right? The variable and the fixed, and minus the opportunity cost of your time, your labor, which is $12 an hour times 2 hours times 50 crafts for $1,200, minus the value of the space in your apartment that you're now using for craft making, which is going to give you a total profit of negative $750. So Your roommate's right. You are making money in an accounting point of view, but from an economic point of view, you are taking losses and you should stop producing your crafts. Does that kind of make sense? I know this one is a little bit on the confusing side. We went over it in class. Hopefully this kind of helps to break it down in a way that makes it a little bit more understandable. Really, the point of this whole section is just to talk about the difference between fixed and variable costs, talk about the difference between explicit and implicit costs, and the difference between accounting profit and economic profit. If you're still confused, let me know. I have another example we can look at. The next homework assignment question is number 4, looking at producing brooms. So Nimbus makes brooms and sells them door to door. We have the marginal product, variable cost, total cost, and average cost we want to determine. We say that it costs $100 a day to hire a worker. So let's go ahead and highlight that for us. And there are fixed costs of $200 a day. So the first thing we want to do is go ahead and find our marginal product. So let's figure out what the marginal product is. The first worker takes us from 0 to 20, so that's a marginal product of 20. Hopefully by this point you're getting more comfortable with marginal product. Second worker takes us from a total output of 20 to a total output of 50. So that's going to be a marginal product of 30. And again, we went over this one in class. The third worker gives us an extra 40 brooms of output. The fourth worker gives us 30. Diminishing marginal returns, right? Diminishing marginal product of labor. The fifth worker gives us an extra 20. The sixth worker takes us from 140 to 150. So that fifth worker is producing an extra 10 units of output. And then the sixth worker gives us 10. The seventh worker gives us 5. And we can see how that marginal product is diminishing because each worker is a little bit less productive. Our variable costs are going to be based on our labor costs. So we're going to have $0 in variable costs when we're not hiring any workers. The first worker is going to cost $100. 2 workers will cost us $200, and so on. We're just multiplying the wages, which is $100 per worker per day, by the number of workers. So if I have 5 workers at $100 each, that's going to be $500. 6 workers at $100 each is worth $600. Oops. And if I hire 7 workers, I pay each of them $100. That's a variable cost of $700 for those 7 workers. Now to get total cost, we want to remember that total cost is equal to fixed cost plus variable cost. So here I've got a variable cost of $0, but I know I face a total cost of $200 a day. So my total cost is going to start at $200 even if I'm not doing anything else, right? But once I start hiring workers, I'm going to have to pay those variable costs plus that fixed cost. So 1 worker for $100 plus $200 for my fixed cost is going to give me a total cost of $300. And then it's just going to keep going, right? Adding an extra $100 for each worker as I make my way through. Oops. Again, here now I've got 5 workers costing $500 plus $200 in fixed costs. It's going to give me $700 and so on until I get to the point where I have $700 in variable costs for 7 workers plus $200 in fixed cost gives me a total cost of $900. Average total cost is just total cost divided by quantity. It's the average of the total cost. So here I have a total cost of $300 and I have an output of 20. So I want to go ahead and calculate that value, right? I'm going to calculate what total cost of 300 divided by 20 is, and it's going to give me the number that I want. Let's do it this way. Boop, it's very important to pick the right color. So 300 divided by 20 is going to be $15. 400 divided by 50 is going to be $8. Then I have, let's see, $500 in total costs divided by an output of 90. That gives me $5.55 or 56 cents. Then I have $600 divided by a quantity of 120. That's going to give me an average total cost of $5. And then we see average total cost starts to even out. And we would expect this to be the point at which average total cost and marginal cost are the closest to each other. So now we have, let's calculate it one more time, $700 divided by a quantity of 140 gives us an average total cost of $5. And then $800 divided by a quantity of 150 gives us a total cost of $5.33. And then $900 in total cost divided by an output of only 155, right? Output has not gone up that much here, right? We've added an extra $100 in total cost, but we've only added an extra 5 units of output. That means that our average total cost is going to be a little bit higher. So far, so good? Okay, for the last problem, we are going to finally graph some of those cost curves that we've been talking about so much. We're going to be graphing average total cost, average variable cost, and marginal cost based on going from a quantity of 1 to 5. So this is a nice, simple, easy number way to practice graphing these curves in price and quantity space. We're going to go from 1 to 2 to 3 to 4 to 5. And then our costs are basically going from a low of 2 to a high of 18. So I'm going to go ahead and put those prices in here. And I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, and then finally 18. And I always like to start with marginal cost, so let's do that because it's my video. You don't have to, it's whatever feels comfortable or makes the most sense to you. This is just what I personally like to do. And you know, we can do really intuitive curves for these, but right now we want to try to be precise as we get a sense of how the graphs should feel and what they should look like. So I'm going to start with marginal cost at a quantity of 1 is going to have a value of $8 or a cost of $8. Quantity of 2 has a value of $2 or a cost of $2. That's definitely that minimum point because at 3 we're already going back up, experiencing those diminishing marginal product effects. As the marginal cost rises, the cost of producing one more unit is getting more expensive because each worker or each unit of variable cost is getting a little bit less efficient. At a quantity of 4, marginal cost is now going to be back up to that initial value of $8. And then at a quantity of 5, it shoots all the way up to the top to $18, really showing that diminishing marginal product of labor and those rising marginal costs giving us that fishhook shape that we are used to, right? The next thing I'm going to do is go ahead and graph our average variable costs. Average variable costs are going to have that symmetrical smile shape, and we can see that going 8 to 5 to 467 to 550 to 8. So it'll start out right here, the same place as marginal cost does, but it's going to fall more slowly with a quantity of 2 having a price of or a cost of $5, and then a quantity of 3 having a price of $4.67, which is a little teensy bit above this $4 marginal cost, right? Pretty close. And then at a quantity of 4, it's going to be $5.50, which is going to be a little bit below marginal cost. And then at a quantity of 8, it's going to be up here at this 8 level, but all the way over here. So that's going to give us this symmetrical average variable cost curve. So far, so good, hopefully. Hopefully this is making nice sense. And then the last thing I'm going to do is go ahead and graph average total cost. it's going to start out really high. And we want to remember the difference between average total cost and average variable cost is going to be the fixed costs associated with it. So for example, if we've got a quantity of 1, average total cost is going to be $18. That tells us that total cost is just average total cost times quantity, or total cost of $18. If variable cost on average at a quantity of 1 is 8, total variable cost is $8, we can infer from that that fixed costs should be $10, right? Because the total cost minus the variable cost is the fixed cost. And at a quantity of 1, that's easier to do. When we get up to the higher numbers, then we have to multiply them by more than 1, but it's fun to do that there. For me, at least. Hopefully you think it's not the lamest thing on the planet. At a quantity of 2, average total cost is still going to be pretty high at a price of $10. And then at a quantity of 3, average total cost is going to be starting to fall down to $8. And then at a quantity of 4, it stays at $8. And we know that's the minimum because that's where it is equal to marginal cost. And then when we get to a quantity of 5, it's going to be back up, rising a little bit above average variable cost, way below marginal cost, at a value of $10. So let's put that right there. And that's going to be our average total cost curve. There you go. We can do the same things we had done on that first assignment where we can talk about how this is the point where diminishing marginal returns set in. This is the point where average variable cost is minimized. Average total cost is minimized here. And we can always think about this idea that there is a marginal product curve or a marginal product of labor. Oh, that was terrible. Do over. A marginal product of labor curve that is the mirror of this marginal cost curve. Because while workers are getting less productive with each additional unit of labor added, the marginal product of labor falling is going to be mirrored by the marginal cost of producing those extra units. So we're going to expect marginal product of labor to peak at the same point where marginal costs are minimized. And then after that is where the diminishing marginal product of labor sets in and the cost of producing another unit starts to really rise. Each worker costs the same amount, but is producing less and less and less. So that's where we see that marginal cost curve come from. And these relationships are gonna, like I said, get really important when we get into the next chapter of material, talking about perfectly competitive firms. And even when we talk about monopolistically competitive and oligopoly firm markets. So that's where we're headed. This is it. That's your whole homework assignment for assignment 6, looking at firm costs and production. Let me know what questions you have. Please do let me know if these answer keys aren't making sense or aren't super helpful. They're meant to be a resource, but if they're not working for you, then it's not a good resource. So let me know what you would rather I do or what would be more helpful or less helpful. And I'll see you next time. Have a great day.